In this video, we're going to explore 3 different ways to take a known Taylor series and Taylor expansion and find similar ones. First one we're going to do is going to involve a composition. So say we want to find the Taylor series for 1 over 1 plus x cubed, knowing this Taylor series here. Well, what we're going to do is we're going to rewrite this so it's in this form. So 1 minus negative x cubed. Now if we think of this as our function f of x, then this is f of negative x cubed, and we'll just do it like a composition. So its expansion is going to be 1 plus negative x cubed plus negative x cubed squared plus negative x cubed cubed plus ... And we'll actually do the same thing over here, negative x cubed to the n. And we'll simplify this a little bit, so 1 minus x cubed plus x to the 6th minus x to the 9th plus ... You can see here we are going to get an alternating series, so negative 1 to the n times x to the 3n. So we didn't have to find the derivatives of this function. We could do it that way. Let's add on to this. What if we wanted to find the Taylor series for x to the 7th over 1 plus x cubed? Well, this is just x to the 7th times 1 over 1 plus x cubed, which we already know the expansion for. So we're just going to multiply all the terms in that expansion by x to the 7th. So its expansion is going to be x to the 7th minus x to the 10th plus x to the 13th minus x to the 16th, and so on. Gives us n equals 0 to infinity of negative 1 to the n, x2. Now what are we doing? We're multiplying by 7. That's going to be the 3n plus 7. So again, a very quick way. You shouldn't have to use the product rule in each derivative doing your Taylor expansion, because what you can do is do the Taylor expansion of one piece and then multiply by the other piece. Let's look at one here that involves derivatives. So we're going to find the Taylor expansion of 1 over 1 minus x squared, and I'm giving a hint. The derivative of 1 over 1 minus x is 1 over 1 minus x, the quantity squared. So if you want, go ahead and double check that, but that means our Taylor expansion of 1 over 1 minus x squared is going to be the derivative of this guy, so it's the derivative of each of these terms. So 0 plus 1 plus 2x plus 3x squared plus 4x cubed plus so on and so forth equals, we can actually just do the derivative of this here, and it's n times x to the n minus 1, and we need to make sure our n begins at the right spot, and because we went down 1, we don't want to start at 0 because it's not going to work out quite right, although we could do 0, but we're going to go ahead and start it at 1, and we'll get the rest of those terms. So that's using differentiation to find a Taylor series. The reverse is going to work as well. Let's say we want the Taylor expansion for ln of 1 minus x, and here's our hint. The derivative of ln of 1 minus x is negative 1 over 1 minus x. That means we need the antiderivative of each term, and we need to make them negative because of that negative there. So let's do this. Let's put a negative here, and let's do the terms inside. I'm going to do the antiderivative term by term. So x plus x squared over 2 plus x cubed over 3 plus x to the 4th over 4 plus ... equals, now we need a negative out front for that negative there. And we're doing an antiderivative, so now it's x to the n plus 1 over n plus 1. And now we need to think about where we want to start our n. we can go ahead and start that at 0 up to infinity. Now, that's not the only option. If I wanted to, I could let these both be n, x to the n over n. And notice where I'm going to want to start now. I'm not going to want to start at 0. I'm going to start at n equals 1 to infinity. So there's a lot of options on how you write these up in summation notation. So again, this was just a little video to show you how you can use composition, multiplication, differentiation, and anti-differentiation to take one Taylor series and find 4 more very quickly. And this works for other Taylor series expansions. Besides 1 over 1 minus x, you can do it for e to the x. So you can very quickly find e to the x squared, or x cubed times e to the x squared. You can do it for sine of x, cosine of x.